Alright, here's another one where I'm going to start with number 18, and then if you hang around I'll give some bonus footage on number 17. Alright, so the first thing I'm going to do is add 2 to both sides, because what I'm trying to do is get this little exponential piece, the -3 or the 3 to the 5x. I'm going to get it by itself, okay, because that's when it will help us to change forms. Okay, so that's going to be negative 86 over here. And now look, so if I were to start now, I would have a log base -3 of negative 86. Okay, but one thing you need to realize is that if you type this into your calculator, -2 squared, it's going to tell you that it's -4. If you type in this, -2 squared, it's going to tell you the truth, which is that that's equal to 4. Okay? All of that to say that this negative sign here is not being raised to the 5x. Essentially what this is -1 times 3 to the 5x equals negative 86. So whatever is happening here, whatever 3 to the 5x is, then we're going to make it negative, and it should be negative 86. So really, if you divide by -1, you see that 3 to the 5x needs to be equal to just 86. Now, we have an exponent that has an x in it, because it's exponential, and so we need to switch it to log form. Okay, but what is the base of my log? The base of my log is 3. Okay, the answer to a log is the power. Okay, so this should be equal to 5x, because that's the power of my log, equals 86. So really just need to focus, before you do anything else, focus on what the definition of a log means. What is this log saying? It's saying 3 to some power is 86. So if you didn't have the right side of this equal sign at all, it would still be asking the same question. What power do I raise 3 to get 86? And the answer is the 5x power. Okay? And then from there we need to divide by 5. And you get x equals log base 3 of 86 divided by 5. One other thing that you could do from this spot right here, let me put this up here again, be a little space. Okay. This is a little more, I think, just intuitive for us algebraically, because we're used to doing this. The do unto one side what you do to the other, log base 3. So I'm going to log base 3 of both sides, because that's the base of my exponential. Okay, 3 to the 5x power. The thing you're raising to a power is your base. So I make that the same base as my log. And the power property of log says that I can take that 5x out front. And now, what is this? Log base 3 of 3, that's just 1. So it leaves me with 5x equals log base 3 of 86, just like we had before. You pick whichever method works best for you. For me, I really like the stuff in the green. I really like that because it helps me see more of what's going on algebraically. It seems like less of a magic trick maybe. But whichever one makes sense to you, go with it, pick it out, and stick with it. I'm going to do number 17 now. In the same vein as before, I'm going to get that 8 to the other side because I want to just be left with this exponential term. So I got 26 minus 8, that's 18. And now I'm ready to switch forms because I can't do anything until I get that 7 minus 6b out of the exponent. So you could do the whole log 5 of both sides, log 5 of both sides. Okay? And doing that really helps you make sure that you've got your logs set up. If you do this method and you just switch forms, I see people get that wrong a lot, but you make sure there that you have the log base 5 of 18. Okay, and what is it equal to? It's just equal to 7 minus 6b. So the next step for us is that we're going to subtract 7 from both sides. You get log base 5 of 18 minus 7. Okay, so 18 is the argument. Minus 7 is just outside the log. Then we're going to divide by -6 on both sides. And I'll come back up here and write the answer, even though it's already written in red there. So now the whole log is negative. And this negative sign right here becomes a plus sign, okay? Because both the log and the negative 7 are divided by negative 6. So that gives us a plus 7 divided by 6. All right, and that is 17 and 18.